Hello, class. This is Mr. McAllen again, and we're going to be doing problems 33 and 34, which will hopefully not take up too much time, but I'm going to get right into it. So the first one we have is um, where we're looking at a polynomial function that may have this graph. Now, when we look at a function like this, the end behavior, you should first look at the end behavior, and it's definitely even and behavior. So the function has got to have a power, a leading term that has a power of 4. And if we look at this, we can right away disqualify, um, well, we can't really disqualify any because all of these, like this will be, leading term would be x to the 6, that would be choice B. This one here, because this is going to be an x squared, this would be x to the 4th, because if you look at all of what the leading coefficients would be, they're all going to be x to the 4th power. So that's not going to help us too much on this problem. I thought it might on first look at the problem. So let's take a look at what else we can do. So let's take a look at the zeros. And sometimes that method where you look at the end behavior, that disqualifies a few candidates from a multiple choice test. So what we have going on here is right here at x equals 0, we have a through root. So we're looking for a 0 of multiplicity, odd multiplicity for a through root. At x equals 1, we have bouncing. So at x equals, we would expect to see from this a term like x minus 1 squared because of bouncing, or an even multiplicity. And right here at x equals 2, we have a through root. So we would expect a term there for x equals x minus 2 would be the linear term that would cover that root of x equals 2, and that would be odd multiplicity. So let's try to construct what the function could be. So here's my plain old x root, the through root. The next one is going to be x minus 1, and I'm going to square it for the bouncing. And the last one is going to be x minus 2 with odd multiplicity for the through root. So let's see if that matches up with anything. And it matches up with A. I think that's a match, except my x minus 2 comes first compared to the x minus 1. So that would be the appropriate answer for this graph, because this is a odd multiplicity through, even multiplicity, bounce, odd multiplicity, through. So that choice would work out great for that one. So I'm going to put choice A. Moving along, this one is a little bit more complicated because it's a rational function, and they give us some information about a horizontal asymptote at y equals -2. So, but first, let's take a look at finding the right ones which have the correct. It says it touches the x-axis at x equals -4. So that's a 0 at x equals -4. So that means you have a 0 there. So I would expect a term in the top of my rational function be x plus 4. It says it touches the x-axis. It didn't say it goes through the x-axis. So that may indicate like a bounce at x equals -4. So I'm gonna consider that for a second. So if it's bouncing, maybe it's squared, but I'm still questionable about that, because a touch could also mean as it goes through. So then we have vertical asymptotes at x equals -2. So in the bottom, I would have x plus 2. That's for vertical asymptote. And x equals 3, another vertical asymptote. So I'd have x minus 3. And now it says I have a horizontal asymptote at y equals -2. Okay, so what that means is when you look at your a horizontal asymptote at y equals -2 means that when you look at the function, and you do you compare, because to have a horizontal asymptote, the numerator order has got to equal the denominator order, right? So in this case right here with this function, my numerator order is order 2, and my denominator order, because when I FOIL this, I will get x squared. So my orders would match, and I would definitely have a horizontal asymptote. at y equals some number other than 0. But if you look at this, the leading coefficient would just be 1. So this problem here, if this was the problem I was submitting, my horizontal asymptote would be y equals 1, because the leading coefficient of the top and the leading coefficient of the bottom would both be 1. So how do we make it -2 in this case? You simply put a -2 up top, and that would be enough to give you a horizontal asymptote at y equals -2. So looking at the answers, oh, and it also says, I have one other clue here I misread. It crosses the x-axis at -1. So that implies that I have x plus 1 in the top for a 0. So now, now I've got the orders are out of balance. So I've got to make sure the bottom has a degree a little bit higher. So I'm looking at my choices, and I see this is the closest one to what I have going on in the top. And in the bottom, oh, they made that squared. So now that means that you have the same order top and bottom, and you will have that asymptote. So I'm going to say choice choice A. I won't choose choice B because I don't have bouncing or touching at where it just touches the x-axis at -4, because there's no bouncing here. Choice C is backwards, so that's completely out. And choice D, the asymptote locations are backwards, so that's out. So my answer, the best answer here is choice A, and that would satisfy all the requirements of this problem. Pretty tricky problem, and I suggest that during the week next week when we're reviewing, we try to do a few more of these just to refresh our memories. So anyway, I hope this helps, or at least refreshes your memory. And last video for multiple choice is the next video for number 35.